Hello, Mike Panaki here. Let me just clean a couple of things up there. We'll get rid of that window. I'd like to welcome you to this Profitap presentation this morning here in Seattle, this afternoon if you're on the East Coast, and I know that around the world, I saw some New Zealand messages go out and so on. So good evening. I got to do this at 1 a.m. Pacific time today for Europe. So excited about the presentation and about talking about how we can optimize traffic flows and network tools using packet brokers. So today is going to be primarily an introduction to where packet brokers fall into our network. Or not fall in, we architect them in. And we're going to talk about why we put them in, what they do for us, and how we can use this as a way to collect traffic from numerous sources, aggregate that traffic, filter that traffic, and then distribute that traffic out to our network analysis tools in an efficient manner. So the goal here is not to overload our network tools with traffic. Also, we want to maintain security. We want to ensure that when we're sending network traffic to a device, that we are sending precisely the network traffic that that device needs, and we're not pushing that out to somebody that shouldn't be seeing that information. So it's really important to note that during this presentation, we have Laurent, who is the CTO of Profitap on the line, and we have Rosario, who's one of the project manager and senior application developer. So they are both watching that Q&A window. So I want you to take full advantage of that Q&A window. And as I'm talking, they're going to be in the background answering questions about what I'm presenting. And so if you have any questions about any of the products that I'm talking about, the technologies we're working with, please don't hesitate to put those in. Then what I'm going to do is toward the end of the presentation, I'm going to go through and we're going to go through some of those questions. And you can go out and take a look at the questions that have been posted out there. But I want to just keep rolling with the presentation. At the same time, we've got two of the best people available for getting those questions answered. In addition, we have John Maudlin on the line, and John is the SE here in the United States. John is available out there as well. So please don't hesitate to send those questions in. We'll work on getting those answered. So with that said, let me go ahead and I'm going to share my screen here, and we will get fired up with our presentation. So don't worry, this is not PowerPoint. I'm not going to PowerPoint you to death today. I've really worked over the years of trying to get away from that. We're going to be creating this presentation as we go. So what we're going to do is we're going to start out taking a more traditional look at how we get in the path of packets and start capturing those packets. Then we're going to see how that doesn't scale. Once we start moving beyond just a few links, we need a way to go in and start collecting traffic from many sources and distribute it to many analyzers. And the thing is, it is absolutely not a one-to-one relationship. Just because traffic's coming in at one point doesn't mean that just one analyzer needs to see that traffic. In fact, in many cases, multiple analyzers may need to see pieces of that traffic. So our goal here is to go through what we can do as we're architecting our network and as we're going in and making decisions on how we're going to monitor and troubleshoot that network. So what we'd love to see you do is start from the beginning. And when you architect out your switches, your routers, all your distribution equipment, your fiber, you take the time to put in a monitoring solution. In the last presentation, I brought it up toward the end, and I'm going to bring it up now, and that is what we want to avoid is that situation where effectively you've welded the hood shut on your car with the assumption that you will never have to troubleshoot anything on that car. Well, that's wrong. There's some cars out there that you may not have to do anything for a very long time, but someday you're going to need to get into that hood. So what we find with our networks is we tend to build networks that are very difficult to troubleshoot. So by taking the time at the beginning to go in and architect a solution that allows you to go in and start monitoring that network before you start having problems, when those problems do occur, you're going to be prepared for it. And it's so much easier to include equipment as part of the original budget than go back later and say, I know we asked for all this money, but now we need more money because we forgot to build a network that we could troubleshoot. So our agenda today is we're going to be taking a look at a traditional approach of how we go in and connect into the network. Then we're going to take a look at how we utilize the Profitap X2 3200G packet broker and the booster. And when we get done with this presentation, you don't get that I'm kind of excited. I mean, the packet broker is a cool piece of equipment. We're going to go through it. I'm kind of excited about the booster. I think it's a very neat little piece of equipment, and it really does boost the capabilities of our packet brokers and our analysis equipment. So even if you're not ready for a full-on packet broker yet, what we're going to find out is that the booster is a great way to get started in here. We're going to look at how we can set VLAN tags on the booster, because one of the things you're going to ask is you're going to say, Mike, this is great, but how do I know where this traffic came in? And I'm going to show you how we can do that with the booster as well. So let's go ahead and move on here. Here we have a simple network, right? This is about as basic as it gets. We've got our router, we've got a switch, and all we want to do is get in the path of these packets and start monitoring what's going on. So first thing we're going to do is put on the old glasses so we can see what's going on here. But what I can do is I can come into this network right here and I can break that link. Now, one option I have is I could come in and I could grab my 1 gig IOTA. Now, the IOTA, we've got presentations on this. We can talk about the IOTA a little bit. In fact, if you have any questions, don't hesitate to send those in, because you've got, again, 2 of the best people, actually 3 of the best people out there to answer these questions. But here we've got our IOTA. Now, the neat thing with the IOTA is the IOTA does capture to disk. So it's got a 1 terabyte drive in it. It's got an integrated fault-tolerant tap. So now I could come in and I could take this cable and plug it into port A. I could take this cable out of port B, plug that in there, and now I'm in the path of those packets. I'm capturing at full line rate 1 gig, or I could put the 10 gig IOTA in there and capture at 10 gig. But I'm capturing this and I'm using Profitap to go in and start looking at that traffic that's going across and seeing who's talking to whom, what applications are running across there. We'll touch on the IOTA. This is not an IOTA presentation, but we're going to use the IOTA to validate the rules that we're creating using the packet broker. So this is great. Now, this requires I break that link. So I've got to break that link to put it in. Now, from a traditional standpoint, a little better option here. Let's see. Let me grab. There we go. So we're going to take our IOTA right here. Technology, always a challenge, but we're going to take our tap. So now what I could do is I could do something like grab a 1 gig copper tap right here. And I could take that 1 gig copper tap and I could throw that in line between that connection. Now, one of the advantages of taking that 1 gig tap and throwing that in line is I do that once. So now I don't have to go back and break that link again. And what I could do in this situation is I could come over here, I could come out of port B, I could grab my monitor port B right here, and I could bring that over into port B of my IOTA. I could take monitor port A, bring that over here into port A, and now I can capture full duplex line rate traffic. But the thing is, I don't have to break the link every time I want to go in and monitor. So from a very simple standpoint, this is where we could go in and we could put a tap in a key location. We could take our monitoring tool and go in and start monitoring. The challenge here becomes when we want to move beyond a simple network. So now we move to a not so simple network. With our not so simple network, we've got a link going out to the internet outside our firewall. We've got between the firewall and the router, between the router and the switches, and between our MDF switch, our IDF switches. We want to be able to come in and monitor that. So now, how do I start approaching this? Well, One option is, this is where I could come in with something like my booster. Now the booster has 4 inline taps right here. So each one of these is capable of tapping into 10, 100, or gig links, passing traffic at full line rate, capturing that or forwarding that traffic out the output port at full line rate. So I could come in and I could start taking, I could break this link, I could break that link, I could break that link, and now let's just say this link. So now, if I come in here, I could take and throw this link in here. I could take this link over here. It starts looking a little messy. But I could start putting this in line with all these links. So now I'm monitoring each of those links. Now, the most traffic that could come out of this would be 8 gigabits per second. That would be all of these operating full line rate, full duplex. So we're not going to oversubscribe our output port. Then I could come in, I could go to my analyzers, I could grab a 10 gig IOTA, I could throw that in here, come out of my 10 gig port. A lot of times I'll just use a DAC cable. I could use a fiber, I could use copper, I could come out of here, plug that in there, and away I go. So now I'm capturing, I've broken into 4 of those links. So we've scaled up a little bit, but what happens in a regular big network, right? I mean, this is still pretty small. So what happens with network monitoring is once you start network monitoring, you become addicted. You realize that you can start monitoring numerous places and collecting all kinds of data. You can capture over extended periods of time, and then you can go in and start taking a look at what happened in the past. So this is where we move up in our network a little bit. We start going in and putting in taps. So like in this case, here is a 1/3 U 8 tap unit. So this has 8 inline taps built into it. So now I've got 8 outputs. Okay. So I step up from there a little bit, and that works really well for tapping my fiber links. So now I want to step that up just a little bit. So I throw in some boosters. So I start putting these boosters in key locations where I want to monitor some copper links. And the nice thing here is I can monitor 10, 100, 1000 copper links, and I can send that out at 10 gig. Well, monitoring doesn't happen unless we throw in our monitoring equipment. So in this case, I've got my network forensics and analytics equipment. I've got my network performance and visibility. I've got my security monitoring. And over here, I've got one of my IOTAs set up. And I'll show you, just like we're going to do today, I can use this for doing network validation. Or for validating the rule sets that I'm going to implement. Also, this gives me back in time monitoring. But here's the thing, there's a 1 terabyte drive on there. If I start dumping all of my network traffic to that, I'm going to fill that drive up in a pretty quick or short amount of time. But if I'm selective about the data that I send out to that analyzer, I can now go in and start extending the amount of time I can capture. And anybody that's gone in and done network troubleshooting knows that you get a call and the person said, hey, had a network problem. You say, when did it happen? Oh, I don't know, like last Tuesday at 3 p.m. So now we need to be able to go back in time and see what happened. So by being able to have a device like that, we don't need something that can capture multiple terabytes worth of traffic if we're sending the traffic to that very selectively. So you'll notice that there's a big gap in the middle. How do we fill in that gap? How do we aggregate this traffic that's coming in from all these different sources, filter on it, and then distribute that out to the devices we're using for monitoring? Okay. Well, this is where our packet broker comes in. So today, we're going to be taking a look at the X2 3200G. This is a 32 port packet broker. Each of these ports is capable of doing 10, 25, 40, or 100 gig. So we've got 32 ports in here. And these ports can be used as input ports or output ports. So as we go in and start configuring our rules and our rule sets, we're going to say that this port is input coming in. This port is output going to one of our pieces of analysis equipment. So now, with these ports, like in the setup that I've got here, what I've done is we come out of one of our boosters right here, and we come into this port right here. Now, this port has a fan-out cable, and that fan-out cable has 4 10 gig connections on it. So I can then take this booster right here, plug that into the second of 4 ports on that one physical port. I can plug this booster into the third one. I can take and come out of this tap and plug that into the fourth one. Plug this one in here. Plug this one in here. So now what you see is if I'm operating at 10 gig, if I have 10 gig links, oops, too far, I can start getting a tremendous number of inputs coming into my packet broker. So now I've got data coming from all different sources within my network, inside the firewall, outside the firewall, in front of servers, in front of key locations where I need to be able to monitor traffic. So within this packet broker, I can now start applying rules. And what we're going to do is we're going to go in and build some rules today and look at how those rules can be implemented. Key features of this packet broker, as well as others, is deduplication. What I want to avoid is if I am tapped in such a way that I see the same packet multiple times, I need to be able to come in and deduplicate that while reducing the amount of latency that I'm adding to that deduplication process. So this device needs to look at those packets and say, these are both the same. We're going to deduplicate that before we send that out to the analysis equipment. But we need to be careful, because if we're too overzealous with the deduplication, we can end up throwing packets away that are not duplicates. And that results in lost traffic. And when it comes to doing analysis, I would prefer to have cases where I have forwarded the same packet twice, then not forwarded a packet that was not a duplicate. And that's what we see here, is this allows us that if it's going to lean toward the side of sending a duplicate packet as opposed to sending a non-duplicate packet falsely or throwing that packet away. So with our packet broker in the middle, I can now come in and start choosing my outputs. And these don't have to be in any particular location on here, but I'm just going to grab this bottom port right here. So I could take and send traffic out to my network forensics and analytics. I could send traffic out to my network performance and visibility. I could come over here. I could send traffic to my security analyzer, and I could send traffic over here to my IOTA. Now, through the rules, I can now come in and I can start setting up that aggregation and distribution process. I can say that I'm going to take the traffic for here, I'm going to send it over here. I'm going to take the traffic for here and send it over there. And I really want to emphasize that not only does this allow us to optimize the analysis tools we have, you may have a piece of analysis equipment that isn't capable of monitoring traffic at 100 gig. But we can come in here and monitor 100 gig links, and we can selectively pull the traffic out of those 100 gig links and send it off to an analyzer that's operating at 10 gig. So what this does is it allows us to take tools that couldn't handle that full fire hose worth of traffic and give them just the traffic they need. And one of the tendencies that we find when people start initially analyzing network traffic is they want everything. I want to see everything. And you can kind of tell as they mature through that process of learning to do network troubleshooting and monitoring, and they'll say, well, you know, I don't want everything. This is what I want. So we're going to go and take a look at how we can set up our rules in here to select exactly what we want. So this is the basic premise of what we're talking about today. And this is where a packet broker fits in. Now, let me just check. I think I've got everything there. So what I'm going to do is we're going to grab our packet broker. We're going to drag that over here. So I'm going to bring over my packet broker. We're going to come up here to device status. So we've got an X2 3200G set up in the back room. We've got it fired up. Pretty easy to connect in initially. Hooked a serial cable to it, gave it an IP address, set up a user ID and password, logged in, and now I've got this web interface. So I'm not going through a separate management console for this. I can web right into my packet broker. Gives me some info about how much traffic, my global traffic that I'm seeing out here, temperatures, how's that thing operating, how are all those fans running. Got a small office here. It's got a lot of fans, so it's keeping the office nice and warm. If we come into port management, this is where I can come in here and I can start taking a look at what's going on with my ports. So it's showing me what ports are active. So right now, I have 3 ports connected. And as I mentioned, we can take these 40/100 gig QSFP ports and break these out into 10 gig ports. So I have this one broken out into 4 10 gig ports by plugging a fan out cable, an MPO to LC fan out cable in there. And I've got this connected up to a booster, and I've got it connected up to an IOTA and to another analyzer. So what we can do is we can start coming in and taking a look at what's coming through there as far as that traffic goes. Now, if I come down here to statistics, what this does is it shows me, I can turn which ports I'm interested in off or on. So I'm interested in ports 1, 2, and 1, 1. So what we find is that on our received, we're receiving about 10 megabits per second on port 1, 2. And that is my booster connected to that. And that booster is in line between my internet connection and the connection running out here to my video studio. So it's really capturing some of that traffic twice. It's capturing on the inside of my firewall, and it's capturing it on the outside of my firewall. Now, if we move down a little bit, port 1, 1 right here is where my IOTA is connected. And the IOTA, we see nothing. We see that we've had some good frames. In fact, I'm going to reset all the statistics here. But we're not getting anything out of there right now. Why? Because we haven't created a rule yet. We've got traffic coming in, but we haven't told the packet broker how we want to send that traffic out yet. That's where our traffic management comes in. That's where we can come in and we can say, you know what? I want to start creating rules. So I've got an example rule set out here. So this is where I can create my rule sets, and then I can activate those rule sets, and we're going to move those rule sets into place. We're going to start forwarding that traffic over. Now, if I come over here to my IOTA, what we see, and I'm going to hit refresh, we've got nothing coming in. So our IOTA, this is a 10 gig IOTA. It's plugged into one of the output ports there. We're not capturing anything. Now, using a tool like the IOTA is a great way to go in and validate that our rules are doing exactly what we expect them to. And this is part of the workflow of going in and building these rule sets. Is first we need to define what it is that we're looking for. I took a look at my voice over IP server to take a look at what SIP servers it's using. So now what I'm going to do is I'm going to create rules to monitor the traffic going to and from those SIP servers, because that's really all I'm interested right now, is taking a look at my voice over IP traffic and analyzing that. I don't care about all of this Zoom web traffic and so on. I don't care about backups that are running. I just want that SIP traffic. And I even want more than the SIP traffic. I want the RTP traffic that goes along with it. So what I'm going to do is I'm going to come in here and I'm going to say I'm going to create a rule set. We're going to call this rule set demo. give it a descriptive name. So now with demo, and come in and start configuring that. So here's where I can create my rules. So how many rules can I have? Well, we can have about 8,000 rules. A lot of rules. And this will go through and take a look and make sure that we don't have conflicts in here with those rules. It is going to go through all the rules, figure out whether a frame should be forwarded or not and where it should be forwarded based on these rules. So I'm going to go ahead and say create a rule. So the first thing with creating a rule is what input ports do I want to use? And that's the thing, is I can pull the data from multiple locations. So if you've attended some of the webcasts that I've done before, you'll know that one of them that I've done is on determining the latency of devices like firewalls and routers. So in order to determine the latency of the firewall and the router, we need to pull the data from each side of that device. So if I have taps in place that are outside my firewall and inside my firewall, I could now come in here and select those ports, grab that traffic coming from those two different locations and aggregate that into a single output port. So now by going in and looking at my analyzer, I could look at the delta time between those two packets and I could determine what the latency of that is. For example, I was out at a school district a number of years ago, and with all of the online testing that's been taking place over the years, what we found is that these school districts can have bandwidth coming into the school that most days works just fine. But then one day, everybody needs to take the same standardized test. So you have thousands, potentially, of students all logging in at the same time. Now, while this may not use up all the bandwidth, in their case, it used up all the NAT connections. So being able to monitor on both sides of something like our NAT server allows us to see things like connections coming in, but not coming out the other side. That we filled up our NAT tables, we can't establish any more connections. Without the ability to monitor on both sides, how do we know things like that are happening? So in this case, I'm going to take port 11, right, or 12 right here. This is going to be my input. That's my booster. I come over here and I'm going to send that out port 11. So now I could come in and I'm going to take that traffic and send that out. Now, if all I did was set up this one rule right here, it would take everything coming in 12 and send it right out 11. That's more than what I'm looking for. I just want to see my SIP traffic. So this is where I come over to my filters. Now, if I knew what MAC addresses I was interested in, I could put in those MAC addresses. And this is another very important component when we're taking a look at packet brokers. And that is that they understand protocols. Because the more protocols that a packet broker understands, the easier it is to go in and create these rules. Because we're able to come in here and I can now say, well, I know that my SIP traffic, my RTP traffic, is using IPv4. So I could come in here and I could put in the source IP address. So I'm going to say 66.241.99.27. Now, we could put a subnet mask on there. If all of my servers were in the same Class C address space, Class B address space, or whatever combination of bits I want to put in there, I could come in and put in a valid mask, and I could be able to monitor a number of devices all at the same time. And this is really useful for things like if I want to go in and take a look at all the traffic going to a specific site. So I'm going to come in here, and now if I did this, what I would do is I'd get the traffic on both sides of my router because I'm capturing on both sides of the router. I just want to get the traffic on the outside. So I'm going to say 50.194.62.33. That's my outside IP address. Now I can come in here, I can say UDP, because this is UDP traffic I'm looking for, whether it's the RTP traffic or whether it's the SIP traffic. Now, if all I was interested in is my SIP control traffic, I could come in and put in port 5060 as my ports. But in this case, what I'm going to do is I'm going to come in, I'm going to say, well, that gives me what I'm looking for. Now, we could come in and apply VLAN or look for certain VLAN tags out here. Now, the booster supports 802.1 AD, and this is Q and Q. So what the booster can do is it can add VLAN tags based on which of the 8 ports that traffic's received on. So we'll go in and we will come in and take a look at that. Also, we can move into advanced, and I could do things like under advanced actions, I could say target action, accept or drop. So what this allows me to do is with my accept or drop, I can come in, I could say, you know what, drop all that traffic. This is very useful for cases where I might have something like a backup server running, and that backup server is using up all of my bandwidth, filling my analysis tools full of traffic. I don't care about it. I could come in and set a rule to exclude that traffic. I want to see everything on this link except for that traffic. We can strip the VLAN tags. We can add VLAN tags. So by adding a VLAN tag, this now lets me know which rule created this. If I create a VLAN tag unique to this rule, I now know which rule created or forwarded that packet. We can strip MPLS. We can do packet slicing. Here we're talking about VoIP. People can get really sensitive about VoIP traffic. And it turns out to do things like get the MOS score, I don't need the payload. I need the RTP header. That's going to give me sequence numbers. I can see delta time, jitter between those. So I could strip off the voice portion of the packet so the audio couldn't be replayed, but I could still use voice analyzers to determine what my MOS score was. Okay. We can do some header stripping, ER span tunneling, GTP v4, so we can come in, collect info or set up filters, etc. on that. Today we're going to stick with a pretty simple one. So I'm going to say confirm. We're going to say from SIP 27. I'm going to turn a counter on there. I'll say confirm. So now we've come in and we've set that up. What I'm going to do is duplicate that. And I don't know if it's Safari in here, but the last one I did, I had a whole bunch of duplicates because I kept clicking on that. But what we're going to do is we're going to come in and we're going to edit that. I duplicated that one. I'm going to go in and edit it. I'm going to say filters and we're going to copy. So we're going to get the other direction. Okay. So I'll say, come in here and we're going to say to SIP 27. I'll say confirm. Okay. And duplicate that one. We're going to edit that. We're going to put in our other SIP server here. Okay. Okay, so I've gone in, I've set these up. So I've got these rules, and what I'm doing is saying saying I want the traffic to and from the 2 SIP servers I know that I'm using. So I will now come in and I'll say, I want to apply that rule set. So now what it's done is it's applied those rules. We've gone in and we're only using 1% of the resources on this packet broker. We've applied these rules. We can now see our counters right here. So with our counters, it's showing us how many frames have we seen for each one of these servers going in out there. And if I come over here to my IOTA, and it takes, on the IOTA, it'll take about 30 seconds for this traffic to start showing up. And that's because with the IOTA, what it's doing is it's writing that traffic to disk. Then it's going back and analyzing that. So we do see a slight delay, but right there, there's our frame, and we see there's that traffic. So I've got my voice over IP phone right here. So I'm going to grab my phone. And I'm going to call my cell phone. So let's go over and look at our counters right here. So I'm going to answer the phone. So we see that our counters are incrementing. Our rules are doing what they're supposed to do. So now we're getting that SIP traffic that's going between my phone, my desk phone here, and my cell phone over there. We can see, that mostly we're using the 27 server right there. So I'm going to go ahead and hang up the call. So now, see how much traffic we've collected? So if we come back over here to our IOTA, and I hit reset or refresh, this is now showing me that traffic that I've seen. So I'm going to give that just a few seconds to get that traffic that's been written to disk analyzed and start showing me what's going on. Now, we are going to spend very little time on the IOTA. There were a lot of questions that came out of the first presentation. People were, well, what about this? What about that? We'll be doing more presentations on that. But in this case, we now have that traffic. And there are some real, I got to show you, there are some cool things in here. We can come in and we can start taking a look at, our different servers, our hosts, what's happening in here. In fact, it'll even start putting this in here as far as, where these various devices are. So we could get an idea of where are our servers, our SIP servers. So for the SIP provider I'm using, roughly where are those servers located? So we see that we've got one just outside of Denver right here. We could come out, we could say, for the clients, where are the clients located? Starts giving us a picture of what's going on. I'm going to come back here to my home screen, take a look at my data. So now I'm going to say, show me the last 5 minutes. So now, once I've drilled in, I'm only looking at my SIP traffic. I'm not inundating myself with traffic I don't care about. So at this point, I could come in and say, you know what? I want to take a look at that traffic I've collected. So I could come in here and say, download PCAP. Okay. So we'll come back. Let me go to my downloads. I'm going to double click on that capture file. Let's drag that over there. There we go. So what I've done, just to kind of recap this workflow, I decided what it is I wanted to monitor. I then built a rule that selected that traffic that I wanted to monitor. I came in, I implemented the rule, and I set it off to my analyzer to validate that that rule's doing what I expect. So now we can start seeing, well, there's our SIP traffic. Here we have our RTP traffic. I can come into Wireshark. I could say, show me what VoIP calls took place. So there's my VoIP call. I could say, you know what, show me the flow on that. It's going to show me my flow of traffic. Oh, that's cool. But really what I want to do is I want to be able to hear that traffic. So now I could come in and say, play it. Let's go over and look at our counters right here. So now I've captured that traffic. So we see that our counters are incremented. Okay, so we hear all kinds of echo and stuff. So now we're getting that traffic. So I'll stop that. But we have now captured that traffic. We can start analyzing it. We can start taking a look at what our jitter looks like, our frame loss, etc. So I've grabbed out just that traffic that I'm most interested in. Now, I'm going to come back here. We're going to close Wireshark. We're done with that. And let's take a look at one more rule on here. Let's maximize that. Okay. So what I'm going to do is I'm going to come in. We're going to edit our rule set. For right now, we're done with these rules. I'm going to get rid of these rules. I'm no longer interested in SIP. What I am interested in is all the traffic that is being captured by the booster on the internet side of my connection. So I could say I want to create a rule. I'm going to bring that traffic in on 1.2. I'm going to send it out 1.1. Well, and we could say internet only. Now, if I come over to my filters, if I left this open, I'd get everything. But what I'm going to do is I'm going to create a VLAN ID group. Now, what I've done is I have set up VLAN tagging on my booster so that the frames coming in on the internet connection on port 1 and port 2 are being tagged with VLAN 500 and VLAN 501. So I can say internet. Say 500 through 501. Say cool. I'll add another one. This is the link coming out here to the video studio. So I'll say studio. Studio is 502 through 503. We'll add that. We'll add one more. And that's the switch that's sitting on my desk that's connected to some wireless APs. I'll say desk. I'll say 504 through 505. I'll add those. Now I can say close. So if I come in, I now have these various groups that I can select from. I can say, you know what? I'm interested in my internet traffic. So now I could come in and confirm that. I could say, confirm. We now have that rule. So we now have internet only. And you know what? Let's do this. Let's go in and edit that real quick. Especially when I'm troubleshooting rules and starting to set them up, it's really nice to turn on the frame match, just so that we can start getting an idea of how many frames are matching this. So now if I come back over here to my IOTA and I hit refresh, we're going to start seeing more traffic coming through, I hope, in just a second. Now, this is a live demo, and we never know with live demos whether everything's going to work exactly like we want. And because it takes just a second for that to kick in there, let me just go back. So we're sending it out. Yeah, we've seen 14,000 frames. Oh, boom, there we go. We got the data. So whew, that's always a relief. So now we've got all of our traffic coming through here. So here's the thing, and I'm going to answer, there's been questions where you come into some of the questions. So it says, so are we taking off the existing VLAN? No, we're doing 802.1q AD, which is Q in Q. So watch this. Let's just grab some traffic here. So we're going to grab this one. We're going to just click on this device right here. And that creates a trace file. That easy. So I'm going to bring that trace file up. So let's bring that, here's that traffic for that host right there. So, well, okay, this is not the best example. I'll show you, we'll do another quick real example and I'll show you. And that's why I like doing these live demos. But here, I've added in VLAN 501. Okay, so I've added that in there. This really doesn't show what I was just talking about, so we'll close that. We'll come over here. Let's get rid of this window. Let's go to our packet broker. We're going to say, you know what, internet only. We're going to dump that rule right there. We're going to add in, create another rule. I'm going to say input here, output here. I'm going to say filters. We're going to say VLAN group. And what we're going to do is filter on the studio VLAN because this has VLAN tags in the traffic. So I'm going to show you how we add those additional tags in there. So I'll say confirm. Turn the counter on there. I'll confirm that. So now, there we go. We got some frames coming across. So in this case, what we're doing is we just jumped into a VLAN link. So if we go back to our IOTA, we're going to give this, let me give it just a minute here to come in there. Well, that's happening. Let me come over here and take a look at some of these questions. We're going to let that. Okay, so one of the questions is, what's the latency of the booster? It's about 400 nanoseconds at 1 gig. Consistent latency, low jitter. Okay. So as I mentioned, with, can we eliminate, so sometimes, and I always love to see when people put in questions that tie right in with something I brought up, and that is, if we have low amounts of traffic, or if we have traffic we want to get rid of, can we set up exception rules? Latency on the visualization, it is about 30 seconds in here. In fact, we can even come in and pick a smaller time frame. Okay. Grab this. Oh. There we go. I must have had a filter applied. Okay. So now we're now looking at the traffic just on that link for the studio here. So I'm going to grab a small amount of that traffic. And let's go ahead and take a look at that. All right. Here's what I wanted to show you right here. Because I am a big, let's show what it looks like. So right here we have our 802.1 AD. So 802.1 AD, we assigned a VLAN to that is collecting or is adding that. And so port 502, that is port number 3 on the booster that's connected to port 1.2. We still maintain VLAN ID 1. So there's our 802.1Q VLAN ID. So we still have that original VLAN ID in there. So we didn't lose that visibility to that VLAN ID, but we are now able to tell exactly what port that was received on, and we can create a filter specifically for that port. Okay. So let me just one of the questions, is there a CLI or API for managing large rule sets? Rosario, the X2 series devices can be totally controlled with their RESTful API. Documentation's available out there. Okay. So, some good questions. Let's switch back. Let me get rid of Wireshark here. I want to wrap things up. We're getting close to the end of the hour, and I really appreciate everybody taking the time to join us for this webcast today. Let's come down here. So let me just draw this real quick and that is what we find when we're using the packet broker is that we have the ability to take a large amount of data right here and start funneling all of this data down here into, let's grab our packet broker. Start funneling all that into our packet broker. We can take inputs from all over the place. And this is the thing that I like so much about implementing packet brokers into the network, is the ability to start taking all of this traffic from all different locations. It's kind of like when you start using syslog for the first time, you go, holy smokes, all of these machines have all this fantastic information. Now I need to start pulling all that together. We run into the same thing when we start running into collecting data. Then it becomes a matter of aggregating that traffic, aggregating all these different inputs, applying specific rules, and then taking that and start sending that out. Let's see. So now, as I have my different pieces of analysis equipment out here, starting to take, and the funny thing is I made that iota really big. It's actually small, physically smaller than pretty much everything else that's in there. But now I have the ability to come in here and start outputting that aggregated, filtered, VLAN tagged, tag stripped, sliced traffic out to those devices. So easy to implement, easy to come in, web interface, and start creating rules so that we can start pulling that traffic out. I am not waiting for somebody to get done with a span port, not waiting for someone to get done using a tap or trying to get to the right location. It becomes a matter of defining what it is I want, setting up the rules to get it, validating that those rules are doing what they're supposed to do, and then connecting my analysis equipment to that. All right. Well, so there's some other questions. So what we find is that, one of them is about what tools out there. So, we have the network packet broker. Now, the network packet broker, for clarification, doesn't actually capture any traffic. It is aggregating, it's taking traffic in, aggregating, deduplicating, slicing, stripping VLAN tags, adding VLAN tags, applying rules, filtering, and then distributing that traffic out to whatever devices we want to use for doing our monitoring. And a lot of this is good. Profitap has the IOTA, which is a great tool for doing back in time monitoring. What we find is that the other tools are really going to depend on what the various groups within your organization are looking for as far as their tools. So these are going to be tool IDS, intrusion detection systems that we could put in to look for attempts to hack into our network. These could be systems that are taking a look at application response times. So the key here is we don't care what you plug in. We will give it the data it needs to get its job done. So that's really the big thing, and make it easy for getting configured up and working properly. Okay. So again, I'd like to thank everyone for joining us today. I hope that you found the information useful. I want to thank Laurent and Rosario for answering questions. It makes my life so much easier as the presenter to be able to go in and present and then have people that are giving you exactly the right answers in the background that can think about the answers and not have to think about what they're going to be presenting next or whether the rule set that they're going to add is actually going to work right. I've been adding these rules. I know that they should work, but you know, live presentations, we can always run into challenges with those. So thank you very much. And if you have any questions, don't hesitate to contact us and we will make sure that we can get an answer. But I'll tell you, I've been very impressed with how easy it is to get implemented. I mean, you see, writing the rules is much like creating a filter for packet analysis. In fact, we could go in and we could do some filtering on traffic and use that as a way to help us figure out what we need to do to filter that out. All right. Well, I hope you have a good evening, afternoon, morning, rest of the day. Stay safe, and I hope to see you again in a future webcast.